Now we are going to see the modified distribution method, shortly known as MODI method. MO for modified, DI for distribution, MODI method. It is also known as UV method. What is the difference between the previous three methods and this method in transportation problem? Means first three methods will give you initial basic feasible solution of the given transportation problem, that is initial transportation cost of the given transportation problem. Whereas in MODI method, which will give you the optimum solution, optimized result, whether we'll be able to decrease the cost which is found by VAM. That is what we are going to find in MODI method. That is called optimum solution. So here we are going to find optimum solution, whereas in the previous three methods we are finding the initial basic feasible solution, that is initial total transportation cost, whereas here we are finding the optimum solution. You can see the difference between initial basic feasible solution and the optimum solution. We have already given you in the previous lectures definitions. We have already given you what is feasible solution, what is degenerate solution, what is optimum solution, basic cells, which are all given in the previous video. You can check with it. Now we are going to solve the problem and find the optimum solution by using MODI method. The same problem that I took, there are two steps involved. First of all, we'll have to find the IBFS by using any of the three methods. For that matter, I have taken this problem by solving VAM method. So that VAM method, which will give you lowest value, whereas northwest corner, for the same problem, northwest corner gives you 128 rupees. Least cost gives you 156 rupees and IBFS gives you 114 rupees. Here I just wanted to reduce further. Therefore, if you wanted to reduce further, then from 114 to reduce further is much easier than we'll have to reduce from 150 to 156 to further 114, then we'll have to reduce. Therefore, it takes much time. Therefore, I am solving the initial basic feasible solution by using Vogel's approximation method. So we have already got in the at the IBFS 114. So now modified distribution method. Before going to solve the problem by using modified distribution method, I just wanted to ensure that the given problem is non-degenerate solution. What is degenerate? Suppose the number of allotments that you get in the IBFS, which is less than m plus n minus 1. What is m plus n minus 1? M is number of rows and n is number of columns. So here m is 3 and n is 4. So 3 plus 4 minus 1. So 3 plus 4 minus 1 is 6. So you will have to have 6 allotments in the IBFS. Then only you will be able to proceed the modified distribution method. 6 allotments. So m plus n minus 1 equal to 6 is satisfying. Therefore, we can proceed MODI method over here. Now, what is the first step? We will have to consider the basic cell. What is meant by basic cell? Basic cells are cells those which has allotments in it. So which means there are 6 cells which are meant to be the basic cell. So initially we will have to assume that let u1 equal to 0. So for all the problems you will have to take an assumptions that u1 equal to 0. So now what are the allotted cells? This one, u1 v1. So which means u1 plus v1 equal to cost 6, from which similarly you will have to write all the values. So that next u1 plus v2 equal to 4. So u1 plus v2 equal to 4. Next allotted cell is u2 plus v1 equal to 8. Next, U2 plus V3 equal to 2. Next, U3 plus V1 equal to 4. Next, U3 plus V4 equal to 2. What we are going to do, taking the initial value U1 equal to 0, we will have to find the remaining values. So which means, what are the remaining values? V1 over here. U1 equal to 0 means V1 equal to 6. Here U1 equal to 0 means V2 equal to 4. So V1 6 means U2 equal to 8 minus 6, you will get 2. U2 2 means you will get V3 equal to 0. 2 minus 2 equal to 0. V1 again 6. 6 means U3 equal to minus 2. U3 is minus 2 means V4 equal to 4. So using U1 equal to 0, we are able to find all the remaining U's and V's. That is U1, U2, U3, V1, V2, V3, V4. All the 7 values we will have to find in basic cells. Now we move on to the non-basic cells. What is non-basic cell? Non-allotted cell. Non-allotted cells. Now I will have to take the non-allotted cell. U1 plus V3 minus this value. In the basic cells, we have written the cost in the right hand side. Now we are taking the cost into the left hand side in non-basic cells. Nothing new in it, the same. So U1 plus V4 minus 5 equal to, similarly, U2 plus V2 minus 9 equal to U2 plus V4 minus 7. U3 plus V2 minus 3. U3 plus V3 minus 6. So we'll have to find the values of all the remaining non-basic cells values. So which means U1, we all know the 7 values. So U1 equal to 0, V3 equal to 0, minus 1 equal to minus 1. Next, U1 equal to 0 again. V4 is 4. V4 is 4 minus 5 equal to minus 1 again. So U2, what is the value of U2? U2 is 2 plus V2. Value of V2 is 4 minus 9 equal to minus 3. Next, U2 2, V4 is 4 minus 7 equal to minus 1. U3, what is the value of U3? U3 is minus 2. V2 is 4 minus 3, that is minus 1 again. U3 again minus 2. V3, what is V3? V3 equal to 0 minus 6 equal to minus 8. Now we'll have to look at all those values in the non-basic cells. So suppose if all those values in the non-basic cells are non-positive, which means less than or equal to 0. Zj minus Cj, which is less than or equal to 0, that is non-basic cells value, is Cj is cast, Zj is U1 plus V1 or U2 plus V3, something like that. Okay. So Zj minus Cj is less than or equal to 0. You can get 0 or negative value. Then we get an optimum solution. Get an optimum solution. So we can stop. The final answer. So what does it mean? It means that we cannot reduce the transportation cost further from 114, which means we cannot reduce the IBFS solution further to the optimum solution. So optimum solution must be equal to IBFS solution for this problem alone, not for all the problems, for this problem. Therefore optimum solution is rupees 114. Suppose if we are taking instead of using Vogel's approximation method to find IBFS, suppose if you are taking northwest corner rule, then the cost will be 128 here, but actual solution is 114. Therefore we'll get a positive value over here, positive value in non-basic cells. Then we'll have to have some kind of some Modi method, some steps will be available. Using those steps we'll have to reduce to 114. That is why, in order to avoid that kind of steps, we already solved the IBFS by using Vogel's approximation method. So if time permits, we'll have one more problem in Modi method, modified distribution method, by using here. Suppose if we get a positive value over here, what do we do? That we'll see in the next class. Thank you.